Welcome to the Deep Dive. Today we're diving into the world of autonomous drones. And we're not just talking about those delivering your groceries. You, our awesome listeners, have sent us research on everything from tiny drones navigating inside buildings to massive hybrids that can cross continents. Clearly, you're already fascinated by this field, so we're going deep on the tech, the applications pushing the limits, and what it all means for computer engineers.
You hit the nail on the head. This isn't about the basics. Your collection really captures the incredible scope of what autonomous drones can do right now and where things are headed. It's not about potential anymore. It's about drones actively changing industries as we speak.
Okay, let's break that down. Looking at this research, I was really struck by a few things a minute. The sheer variety of drones being developed, the applications, and the computer engineering challenges. Where should we even start?
Let's start with applications, because that's where you see the huge need for computer engineers. You sent research on drones in agriculture, archaeology, search and rescue. It's almost like they're being used for everything.
Right. And it's incredible how the drones themselves are evolving alongside those applications. One paper even mentioned nano drones, so small they can navigate inside a machine to look for defects. And then there are these hybrid drones that can take off and land vertically like a helicopter, but then fly long distances like a plane.
Absolutely. That kind of innovation in design comes from what we need the drones to do.
Yeah.
Take those hybrid drones, for instance. They're perfect for package delivery, right? Vertical takeoff and landing means they can operate in crowded cities, but that long-range efficiency is how you reach those in rural areas too. But that transition, going from vertical to horizontal flight, now that's a massive engineering challenge.
So that's where our computer engineers step in. It's not just about designing the drone itself. It's about the brains behind it, making it all work.
Exactly. Think about what we're asking these machines to do. Perceive their environment, make complex decisions, navigate sometimes unpredictable situations, all in real time, and often with limited onboard computing power. That's where the real ingenuity of computer engineering comes in.
Wow. It's like we're trying to replicate the senses and decision-making of a trained pilot, but in a system that could be the size of my fist. What are some of the biggest challenges they're tackling when it comes to the software and systems that power these drones?
Well, take a simple task like avoiding obstacles. Drones need to see their surroundings, right? Which means relying on sensors like LiDAR, radar, or even cameras, especially when GPS isn't reliable or available. But then, that data has to be processed in real time to figure out if something is a hazard or not.
And on top of all that, they have to make split-second decisions about how to avoid those obstacles, right? Like, what's the safest option? Swerve right, go up, or just hover in place until the path is clear.
Exactly. And this all has to happen while following airspace regulations, factoring in things like wind, and maybe even coordinating with other drones in the area. It's incredible, a whole symphony of calculations and decisions happening every millisecond.
It's mind-blowing. So much is happening behind the scenes that we just take for granted when we see a drone flying smoothly through the air. It really is like the tip of the iceberg.
That's a great analogy. We only see the smooth flight, but underneath there are layers of complex algorithms, sensor fusion, communication protocols. It really highlights how far computer engineering has come.
Makes you realize those sci-fi movies with swarms of drones working together, that's not as far-fetched as it seems, is it?
You're right, it's closer than you might think. Researchers are already working on swarm robotics, where multiple drones work together to achieve a common goal. We could be talking about anything from mapping disaster areas to coordinating deliveries across a city.
This is where it gets really interesting for me. The level of autonomy these drones need. We've talked about avoiding obstacles, but some applications, search and rescue in disaster zones, for instance, require a whole other level of decision-making, right?
Absolutely. We're talking about drones that can adapt to changing environments, make decisions with incomplete information, potentially even learn from their experiences and improve over time. That's where AI and machine learning come in.
So we're not just programming these drones with fixed rules, we're teaching them to think for themselves to a certain extent.
In a sense, yes. We're giving them the tools and data to analyze situations, weigh potential outcomes, and choose the best course of action. It's similar to how we teach human pilots, but instead of instincts and years of experience, we're using algorithms and data.
Okay, so that's the software side. But even with incredible software, don't these complex operations require a ton of power? How are they dealing with battery life, especially for long-distance flights or extended missions?
That's another massive area of focus right now. Think about it. These drones are packed with sensors, processors, communication systems, all drawing power. The more complex the task, the more power it needs.
So a drone delivering a pizza a few blocks away is one thing, but a drone inspecting hundreds of miles of power lines, that's a whole other ballgame.
Exactly. And that's why there's this huge push for more energy-dense batteries, more efficient power management systems, and even exploring alternative power sources like solar or hydrogen fuel cells.
It seems like battery technology is a limiting factor across so many fields right now, not just for drones.
It's definitely a bottleneck, for sure, but it's also driving incredible innovation. Look at how much lighter and longer lasting your phone battery is now compared to 10 years ago. Similar progress is happening with drones. Researchers are always pushing the boundaries of what's possible.
That's good to hear. It seems like every time we hit a technological roadblock, somebody, somewhere, finds a way to break through.
It's the nature of innovation, isn't it? But it's not just about finding solutions to individual challenges, it's about how those solutions come together to shape the entire field.
You're right. Let's zoom out a bit and think about the bigger picture. We've talked about the incredible potential of autonomous drones, but there's always another side to the coin. What are some limitations we should be aware of as this technology continues evolving?
Well, it's not all smooth sailing. One of the biggest hurdles, besides battery life, is safety and regulation, especially as we integrate these autonomous systems into our airspace.
That makes sense. We're talking about sophisticated machines flying overhead, so safety has to be the top priority. What are we doing to address those concerns?
A lot of work is happening on several fronts. For instance, researchers are always pushing the boundaries of battery tech, developing more energy-efficient drones, and even exploring alternative power sources like hydrogen fuel cells.
Okay, so improving battery technology is key. What about regulations? I imagine things get a little complicated there.
You're right, it's complex. Organizations like the Federal Aviation Administration are working hard to establish clear guidelines and standards for autonomous drone operation. This involves things like setting airspace regulations, ensuring secure communication to prevent hijacking, and finding ways to integrate drone traffic into our existing air traffic control systems.
Wow. It sounds like a massive logistical challenge, ensuring that these drones can operate safely and efficiently alongside traditional aircraft.
It is. And it's not just about preventing those mid-air collisions, it's also about addressing concerns about noise pollution, privacy, and even the potential misuse of this technology.
Those are all critical considerations. It's great to be excited about the applications, but we can't ignore the potential downsides either.
Absolutely. It's about finding that sweet spot. Promoting innovation while still guaranteeing public safety, addressing ethical concerns, and ensuring that this technology ultimately benefits society as a whole.
It's clear that autonomous drones could reshape our world in profound ways, but it's not a future that will unfold without careful planning and human judgment. But before we get ahead of ourselves,
You're right. We haven't even scratched the surface of the amazing advancements in drone design itself. For example, did you know some drones are being designed after birds and insects with flapping wings and incredible maneuverability?
you're kidding.
Yeah.
Flapping wing drones, that sounds like something straight out of science fiction.
It might sound futuristic, but researchers are finding that mimicking nature allows them to create drones that are more agile, efficient, and even quieter than traditional designs.
Wow, that's amazing. It's fascinating how nature continues to be an inspiration for technological innovation. Tell me more about these bio-inspired drones. How do they actually work? What are their advantages?
It all comes down to biomimicry. That's about taking inspiration from nature to solve those tough engineering problems. For example, flapping wing drones use a special mechanism that actually copies the way a bird's wings move. So instead of using rotors, they generate lift and thrust through those flapping motions.
So no more rigid propellers like we're used to seeing. These drones actually move their wings like a real bird. That's incredible. What's the advantage of that? Does it make them faster?
Not necessarily faster, no, but think about how birds fly. They can weave through tight spaces, change direction instantly, even hover in place. That kind of agility is really hard to achieve with traditional drone designs, especially when you're talking about smaller drones.
Ah, I see what you mean. It's about being precise and having that fine control, particularly in those cluttered environments where a typical drone might have a hard time. What about the noise? Those rotors can get pretty loud.
That's another area where these flapping wing designs really shine. They're much quieter. Imagine trying to use a drone for wildlife monitoring. The last thing you want is the drone itself scaring away all the animals you're trying to observe.
You've got a point there. And even in a city, I imagine a quieter drone would be a lot less intrusive for everyone. Are there any other advantages to mimicking nature when it comes to drone design?
Well, energy efficiency is a big one. You might be surprised to learn that the way birds and insects fly is incredibly efficient. When they flap their wings, they actually create tiny whirlwinds of air, vortices that help to increase lift. That means they need less power to stay in the air.
So we're talking quieter, more agile, and more energy-efficient drones just by taking cues from nature. That's remarkable. Bio-inspired designs could really be a game changer for the future of drones.
They have incredible potential, no doubt, and we're not stopping at flapping wings. Researchers are also working on drones inspired by insects, creating these teeny, lightweight machines that can navigate really complex environments.
Insect drones. Okay, now we're talking about the future. What are the biggest hurdles when you're trying to be something that small but still make sure it can actually do something useful?
That's the thing about miniaturization. It's always a challenge. Trying to fit in enough processing power, all those sensors and the battery that can actually keep it running, all in such a small space, it's tough. It's all about striking that balance between what it can do and how small you can make it.
So when we talk about these insect-sized drones, what kind of applications are we imagining? What could they do that a bigger drone simply couldn't?
Picture this. There's been a building collapse, and you need to locate survivors. Sending human rescue workers in is incredibly risky, and a larger drone might not even be able to fit through the debris. But a whole swarm of these tiny insect-like drones, they could potentially navigate those tight spaces. They could even use sensors to pick up on heat signatures or sounds that might lead them to a survivor.
Yeah, that's what I'm talking about. That's like something a search and rescue team would dream of having. The possibilities for these smaller drones seem almost endless.
They really are. And the more we learn from nature, the more we discover just how much potential there is for innovation in how we design drones.
You mentioned swarms of drones earlier. It feels like we're shifting gears here, moving away from focusing on what a single drone can do and toward this idea of them operating together as a team. Are you seeing more research in that area?
Absolutely. Swarm robotics is a captivating field that's really gaining momentum. The basic idea is that if you can get multiple drones to work together, communicating and coordinating their actions, you can accomplish things that would be impossible for just one drone on its own.
I could definitely see how that would be valuable in a search and rescue scenario, for instance. You'd have multiple drones covering more ground, sharing information. Are there any other situations where that type of teamwork would be crucial?
Think about large-scale agriculture. Instead of using a single drone to survey a whole field, imagine a coordinated team of drones working together, each one assigned to cover a specific section, and they're all communicating with each other to create a complete picture of the crops. They could be looking at things like crop health, whether the fields need more water, or even if there are any signs of pests.
Now, that's taking precision agriculture to a whole new level. It seems like the more we delve into the applications of autonomous drones, the more possibilities emerge. What's the most surprising or unexpected application you've encountered in your research?
That's a tough one. There are so many incredible applications. But one area I find particularly fascinating is how autonomous drones are being used in archaeology. Archaeologists are now using drones equipped with LiDAR. That's a technology that uses lasers to measure distances to create these incredibly detailed 3D maps of archaeological sites.
Okay, I'll admit, that sounds pretty cool, but how does that actually help archaeologists?
Well, if you think about traditional archaeological digs, they involve a lot of, well, digging. And that can be incredibly time-consuming, expensive, and there's always the risk of damaging the site itself. But drones provide a different approach. Archaeologists can now survey vast areas quickly and without disturbing the site, allowing them to pinpoint potential areas of interest before they even bring in the shovels.
So they're like high-tech flying archaeologists mapping out hidden structures and artifacts from the sky. That's incredible. Are there any limitations to what LiDAR can detect? Could it potentially miss something buried deep underground?
You've hit on a really important point. That's one of the main challenges with any kind of remote sensing technology, whether it's LiDAR, radar, or even ground-penetrating radar. The deeper something is buried, the more difficult it becomes to detect. However, even if LiDAR can't see something directly, it can still often pick up on those subtle changes in the ground surface or even the vegetation that might hint at something interesting hidden beneath.
So it's kind of like a detective piecing together clues to solve a mystery, even without finding that crucial piece of evidence. It's amazing to see how this technology is changing the way we explore and understand our past.
It really is. And it highlights the wider impact autonomous drones are having. It goes beyond just delivering packages or inspecting infrastructure. They're giving us entirely new tools to explore our world, from the deepest parts of the ocean to the vast expanse of space.
It really feels like we're living in a science fiction novel, except it's all happening right now. But with all this talk of incredible possibilities, we have to acknowledge that there's also a potential downside to this technology. We have to address that.
You're absolutely right. With any powerful technology, there comes a responsibility to use it wisely.
So let's talk about that. What are some of the ethical issues surrounding the use of autonomous drones? What risks do we need to be aware of?
It's a real balancing act, finding that right approach. We get caught up in the potential benefits, but we can't forget about the potential downsides. And with these drones, privacy is a major concern.
Yeah, that makes sense. Most of these drones, no matter their size or purpose, have cameras, sensors. They're gathering information, and as they become even more sophisticated, they're only going to collect more and more data.
You're absolutely right. And it's not even just about the data itself, it's about how it's used, who has access to it, what's being done to prevent it from being used in the wrong way. Imagine a drone being used for a good purpose, like monitoring traffic patterns to improve how a city is planned. While that same data could be used for surveillance, and that can feel like a real invasion of privacy.
It's a lot like those conversations we're having now about facial recognition technology or how our data is used online. It's not always that the technology itself is good or bad. It's about how it's designed, how it's used, and maybe most importantly, how it's regulated.
Exactly. And that's why it's so important to be having this conversation now while this technology is still being developed. We can't wait until there's a problem. We need to be proactive. That means engineers, the companies building these drones, policymakers, even the public, we all need to be part of this discussion.
Because ultimately, these drones are going to be operating in the same skies we share. They'll be in our cities, maybe even interacting with us directly someday. We deserve a say in how that future takes shape.
Absolutely. And this is another area where computer engineers have a crucial role to play, even beyond those technical challenges. They're not just writing code, they're shaping how this technology impacts society.
That's a really powerful thought. If we can make engineers more aware of the ethical side of things, maybe they can design systems that are inherently more protective of our privacy, systems that are more secure, systems that are less likely to be misused.
Exactly. We need to bake those considerations into the design process from the very beginning. And to do that, we need to rethink how we approach engineering education. It can't just be about technical skills anymore. We need to emphasize ethical reasoning and social responsibility.
So it's almost as if computer engineering is evolving into a social science in a way,
Mm.
blending with fields like law, ethics, even philosophy. That's a lot for one profession to handle.
It's a big challenge, no question. But I'm optimistic. This next generation of engineers, they seem much more aware of these broader implications. They're ready to have those conversations.
Well, it is encouraging.
Mhm.
So as we look ahead, what are you personally most excited about in this world of autonomous drones? What's caught your attention?
Oh, that's a tough one. There's just so much going on. But honestly, what really excites me is the potential for these drones to make a real, tangible difference in people's lives. I'm talking about things like using drones to deliver medical supplies to places that are hard to reach, or to improve how we respond to disasters, even to monitor the environment and help us protect our planet.
Those are the kinds of applications that can truly change the world, not just technologically, but socially and environmentally as well.
You got it. That's what makes this field so captivating. It's not just about pushing the limits of what technology can do, it's about using that technology to build a better future.
I think that's a great place to leave it. It's been an incredible journey exploring the world of autonomous drones with you today. Thanks for walking us through the technology, the challenges, and all that potential.
It's been my pleasure. Like we've been saying, this field is constantly evolving. Who knows what incredible advancements we'll see next?
And to everyone listening, thanks for joining us on this deep dive. We hope you've learned something new today, and maybe this has even inspired you to explore the amazing world of autonomous drones a little further on your own. Until next time, keep those minds curious.